You need to know the hazards of the confined space that an entrant might face. And the first one is engulfment hazards. When there's grain present, sand, water, or other potential engulfment materials, the mode of suffocation is entrance is covered or partly covered by material. Behavior aspects is no response to calls or he stops breathing. Someone yesterday asked about what if there was too much oxygen in the atmosphere, and when there's too much oxygen, this means this means it's a serious fire hazard. A sign of oxygen enrichment is when oxygen levels are above 23.5%, which can cause clothing, hair, and other flammable materials to burn violently when ignited. Oxygen is not flammable, but it alters the burning characteristics of many materials, making them easier to ignite. In addition, atmospheres enriched the oxygen also permit flammable gases and vapors to ignite over a much wider range of concentration than possible in ordinary air. Care must be taken to ensure that oxygen lines and cylinders are not taken into the space and there are no oxygen leaks or potential sparks. Oxygen-enriched atmosphere may be created when workers use oxygen to ventilate a space or to power pneumatic hand tools under the mistaken belief that oxygen and air are the same thing. Fires under these conditions will burn with great speed and intensity. The behavioral effect on the entrance include disorientation. However, behavior effects to entrance will not likely be noticeable when oxygen enrichments occur. The best way for this to happen is to monitor the situation. Flammable atmospheres are caused by a mixture of dust, gases, and vapors that can explode or catch fire. The mixture cannot burn if there is not enough fuel, or if there is too much fuel. The explosive range is defined as the area between the lower explosive limits, LEL, and the upper explosive limits is UEL. Behavioral effects are nausea and dizziness. Combustible dust concentrations are usually found during loading and unloading and conveying grain products, nitrate fertilizers, finely ground chemical products, and other combustibles. High charges of static electricity, which rapidly accumulating during periods of low humidity, below 50%, can cause some substances to spark and ignite a flammable atmosphere. These sparks may cause explosions. You have heard different times when, grain bins or something like that will explode because of this type of atmosphere. To ignite airborne combustible dust must be a concentration that meets or exceeds its LEL. Each type of dust will have a different LEL. Source of ignition includes open flames, arcs from electrical equipment, hot surfaces, static electricity, friction sparks. So anytime you have a spark, any type of spark, it can cause an explosion. It's difficult to monitor for combustible dust LEL, so OSHA refers to a visual test. Airborne combustible dust is above its LEL if the dust obscures vision is at least a distance of 5 feet. The behavioral effects on entrants include coughing, sneezing, and difficulty breathing if not wearing appropriate respiratory equipment. If wearing appropriate respiratory protection, behavioral effects will not be noticed, so the space will need to be visually monitored continuously to determine if the dust obscures visions at a distance of 5 feet. Toxic gases present two kinds of risk in confined spaces: asphyxiation and irritation. Asphyxiation gases can cause asphyxiation by displacing oxygen in the atmosphere or disrupting the body's ability to use oxygen. Those gases that produce no effect on the body and are present in sufficient quantities to displace the air are called simple asphyxiations. Examples include nitrogen and methane. Substances that incapacitate the body's ability to utilize an adequate oxygen supply are called chemical asphyxiations. Examples include carbon monoxide and hydrogen sulfide. Irritation or corrosive atmospheres can be divided into primary and secondary groups. Primary irritants cause surface or skin irritations and don't affect the entire body. Examples are chlorine, ozone, hydrochloric acid, hydrofluoric acid, sulfuric acid, nitric dioxide, ammonia, and sulfuric dioxide. A secondary irritant may produce systematic toxic effects in addition to surface irritation. Examples include benzene and carbon tetride. Monitor the space with carbon monoxide. The PEL is 35 points per million. The PL for hydrogen sulfide is 10 ppm, or points per million. Check entrance for behavioral effects. Exposure to hydrogen sulfide will cause unconsciousness. Early stages of carbon monoxide intoxication are nausea and headaches. Refer to the MSDS for specific and behavioral effects of exposures to other toxic substances. Continuing on toxic substances, you should monitor for carbon monoxide, hydrogen sulfide, and other toxic chemicals. Check entrance for behavioral effects like nausea and headaches, unconsciousness. Refer to MSDS sheets. Refer to the MSD sheets for specific behavioral effects of exposures to other toxic substances that might be present also. Immediate dangerous to life or health, IDLH, means any condition that poses an immediate or delayed threat to life. That would cause irresistible adverse health effects, or that would interfere with an individual's ability to escape unaided. IDLH hazards is an immediate threat to life, interferes with ability to escape. Check the MSDS for IDLH exposure limits. Behavioral effects include unconsciousness and death. The IDLH, immediately dangerous to life or health, means any condition that poses an immediate or delayed threat to life, that would cause irreversible adverse health effects, or would interfere with the individual's ability to escape unaided from a permit required confined space. All confined spaces should be considered IDLH until proven otherwise. There are also physical hazards. Surface residue can increase the hazardous conditions of electrical shock, reaction of incompatible materials, liberation of toxic substances, and body injury due to slips and falls. Structural hazards such as baffles and horizontal tanks, trays, and vertical towers, bend in tunnels, scaffolding, or overhead structure members are hazards that exacerbate by physical surroundings. Do not introduce electrical hazards such as lights or equipment. They can cause explosions, so use explosion-proof lights. Noise problems are usually intensified in confined spaces. This increases the risk of hearing damage and may disrupt verbal communication with emergency standby personnel. Whole body vibration may affect multiple body parts. Segmental vibration appears to be more localized in creating injury in the fingers and hands of works using tools such as pneumatic hammers, rotary grinders, and other tools that cause vibration. Biological hazards can come mainly from contaminated water. In areas of many cause hepatitis and salmonella, and E. coli, and parasites. Workers in confined spaces are also prone to heat exhaustion, heat cramps, and heat stroke. Again, with the physical hazards, you need to visually inspect, determine the entrance will be performing work that creates hazards such as using electrical power tools, exposure to noise, vibration, and heat. Before entering any confined space, workers must follow all lockout, tagout procedures in order to control all the potential physical hazards in a confined space. The behavioral effects on entrance include slips, trips, and falls, difficult communication due to the noise, and muscle cramping because of the onset of heat illness.